All right. So welcome everyone to the 8th installment of our evaluation seminar series, this month focusing on data visualization. My name is Marianne Obi. I'm a monitoring and evaluation specialist here in the evaluation division, and I'm very excited to be talking to you today about one of my favorite topics. So let's jump right in, starting with what is data visualization? So data visualization is the graphical representation of information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to understand trends, outliers, and patterns in data. So we use data visualization to answer questions about our data, to discover new insights, so to learn things about what our data is saying, to then take take what we've learned and the new insights we've discovered and communicate them quickly and effectively to our stakeholders, and then to add objectivity to an argument. So once we've learned something about our data, usually we may want to take those findings and convince stakeholders to do something or to take action for us or on our behalf. And data visualization can lend objectivity to convince people to do things by presenting data in an objective way, by showing the evidence we have behind the argument we're trying to make. And let's look at an example of how all of this works. Does anyone know what this map is? Feel free to either use the chat box or to just take yourself off of mute if you happen to know. It is a map of London. Yes, so it's a map of London. That's right. Does anyone know maybe specifically what it is? It's all right if you don't. So this is the Broad Street cholera outbreak map, which was created in 1854 by a gentleman named John Snow, not of the Game of Thrones variety. And this map is essentially an early dot map visualization. And so it's using, as you can see in here, hopefully, it's using small bar graphs on various city blocks to mark the number of cholera deaths at each household within a specific London neighborhood, specifically the Broad Street neighborhood of London. So, looking at this map, what question is the map trying to answer? So using the information that it's marking the number of cholera deaths, what question might the map be trying to answer? Exactly. What are the hotspots? So where are cholera deaths concentrated within this neighborhood? And then, so what insights might it have helped discover? Using this map, by trying to answer the question of where are the hotspots, what would the creators have learned from using this map? You don't need to necessarily know specifically if you want to just take a guess. So stay away from that one particular household. I would also maybe infer that. So where tainted water might be. So that's exactly correct. So what they learned from putting this map together was that households that suffered the most from cholera deaths happen to also all be using the same well for drinking water. And then when they took this trend from this particular neighborhood and applied it to the rest of London, they were able to see the same trend throughout the rest of the city, which helped trace a clear line between cholera, and contaminated wells. Which also meant that by plotting deaths on the map, you could very clearly see that trend, which meant that you could very quickly communicate the existence of that trend to stakeholders that needed to see it and that needed to understand it. And then lastly, what argument might this lend objectivity to? So what solution might there be to this problem that you could use this map to help support? So where do you repair resources for repairing wells? That might be one. Any other ideas or thoughts? Right. So I mean, it's lending objectivity to the argument that cholera is being transmitted through water. This might also, help show where there should be boundaries for an effective quarantine. What actually happened back in 1854 was that they were able to use this map to help pave the way for eventually building a sewer system within London. So by showing and proving that cholera deaths were linked to contaminated well water, they were able to show the need for an actual sewer system. All right. Now, this is one of my I like having actual numbers behind saying, not just being able to say that the data visualization increases comprehension of information, but there's actual empirical evidence behind this. So back in 2012, a couple of researchers put out a paper called The Illusion of Predictability: How Regression Statistics Mislead Experts. And what they did was, noting the prominent use of statistical data in academic literature, the authors of this paper asked 257 economists to review a series of studies and then make assumptions based on the different ways that data was presented within each of those studies. So they were all asked to read a bunch of different studies and then make assumptions about what the data was saying in each of those studies. For the papers where only the statistical outputs were presented, so only tables of numbers, 28% of the assumptions made were correct. In papers where there were statistical outputs and graphical representations of that statistical output, 39% of the assumptions made were correct. In papers where only graphical representations of the data were presented, almost all of the assumptions made about the data were correct. So they were able to show that essentially that data visualization increases our comprehension of findings of data that is presented in this case in academic papers, but that can follow through to any other situation where you may need to present data to stakeholders. So, what are the components of good data visualization? There are three, starting with the underlying data that you're using, the visual itself, and then the narrative that visual is trying to tell. Now, we don't have time today to start talking about underlying data and how to make sure that you have good underlying data. Luckily, we have a number of previous evaluation seminars you can go to, which can help with that, including creating and evaluating surveys, data cleaning and analysis, and then working with qualitative data, all of which you can find on our website. But today we'll really focus on creating good visuals and creating narratives for your visuals, starting with visuals. So I have for you today 4 principles of creating good visuals. The first one being selecting the correct visualization for your data. And what this really focuses on is selecting the right chart or graph to match what you're trying to say with your data. So for example, if you want to compare different values within your data set, for example, if you want to compare perceptions in the United States of participants across different countries, or the perceptions for your female participants versus your male participants. There's a specific collection of charts that you might want to use, which include bar charts or column charts. One of my personal favorites, which is the lollipop chart, where it's essentially just a column chart, but it looks like a lollipop, or a bar chart or a box plot is also very common. Trends, which is when you're trying to plot the trend in your data or show the change over time. This might mean if you want to show how perceptions change over a number of years, you would generally want to use maybe a line chart. You could use a column chart. You can also show correlations within your data. So this is when you want to map the relationship between 2 variables in your data. So perhaps you want to show perceptions of the United States as it relates to the age of your participants. Though I have to, of course, caution you that you always need to be very mindful. Unless you tell readers otherwise, they will generally assume that the relationships you present are causal. In other words, that one variable is causing the other to happen. So for showing relationships, you can use scatter plots or bubble charts. Heat maps are also very popular. And then lastly, you can show part to whole relationships. So this is when a single entity is broken down into component charts. For example, you might want to show the percent of your participants that are male or female, or the percent of participants that have various degrees or are at various education levels. Pie charts are the most common here. We're all probably very familiar with the pie chart, but tree maps and then stacked bar plots are also used very, very often. And then Venn diagrams fall into this category. These are only 4 different categories of visualizations of charts and graphs that you can use. There are a number of others, and I'll show you some resources at the end of this presentation to help you make decisions on which visualization best fits your data and what you want to say about your data. So this visualization is from a 2013 study that came out of Harvard University that shows various types of visualizations and how popular they are in different sectors. So for example, scientific publications, and then all the way over here, government and world organizations. And so what I find really interesting is you can see that here in government, we apparently really like to use our bar charts, whereas scientific publications are apparently quite drawn to diagrams and line charts. So you can just see where different kinds of visualizations are the most popular. All right, so then moving on to our second principle is to not distract from your data. And this is where I get to talk about chart junk. So chart junk refers to all of the visual elements within charts and graphs that are not necessary for the comprehension of the information presented on the graph. It's anything that is distracting your viewer from the information you want to present. So, can anyone think of chart elements that might be considered chart junk? All right, so sometimes numbers might be, so numbers, labels sometimes can be considered chart junk if you don't need them for, if you don't need to see them in the trend. There are a number of different things. Artistic boundaries on a bar chart, exactly. You know, they might look fun and exciting, but oftentimes they can be incredibly distracting. Anything else? Long titles, exactly. Titles can sometimes just be more confusing. Your font, hard to read fonts, can both just be a comprehension block. You may just not be able to, if you can't read it, then then your reader's never going to know what's happening. So I have that are sort of the most common junk are color can be great and can point your viewer towards what's important, but poor use of color can often be considered chart junk. Fill, so fill within bars of a bar chart or even background fill. Grid lines, so the grid lines going across your chart can often distract your reader as they're trying to see the level of different bars. And then the mother of all chart junk, having your graph in 3D, because it distracts from the it distorts the proportion of everything. All right. So as we watch through this gift, you'll be able to see how it starts off with a whole bunch of visual elements. And as the visual elements are removed, you're able to much more easily see the data that's being presented and the main piece of data that the creator wants to focus on, which in this case is the amount of calories in bacon, apparently. So you see how it starts versus where it ends. Just highlighting the importance of simplifying your graphs, moving that's not necessary. All right. And then moving on to visualizing your data in a way that increases comprehension. So you want to make sure when you're putting a visual together, you want to ensure that you're not keeping your audience guessing about the variables you want to correlate, and that the main point that you care about is clear to your reader. And there are a number of different ways that you can do this. For example, the way you order your categories matters. You can do alphabetically, so putting your categories in alphabetical order. By value, so as opposed to alphabetical, going by their actual value, or sequentially. And sequentially is generally most common if you're looking at if you have months, if you have age data, if you're presenting data, for example, if you have level of education, you would generally present the data starting at whatever the lowest education level is, going to the highest. You generally wouldn't do that alphabetically or by the value of the data. And then some considerations when you're looking at your chart titles or your labels. So making your chart title as concise, but also as descriptive as possible. So, you know, long titles your reader is going to stop paying attention at some point. Labeling your axes correctly, but also consistently. Avoid using acronyms unless it's an acronym that's very widely known. And then label your lines directly on the chart directly. So if you don't need to use a legend, so avoid using legends wherever possible, and sometimes it's not going to be possible. And then highlight the main point that you're trying to show. So in this example, we're looking at high school graduation rates in the US and trying to show that they've been increasing over the last 6 years or so, which means that the creator of this chart has highlighted the last year. But then also you can identify specific relationships. So in this example, we're showing earnings and unemployment by education level. It's clearly stated within the title, and then that means that the reader knows to look at unemployment and earnings, and then by various education levels to see what the relationship between the two, or between those various variables, is. And lastly, use color and icons appropriately. When I was speaking about chart chunk, I mentioned that color can be distracting, but you can also use color to highlight your main point and to guide your reader through a visual. So you can direct your viewer's attention to maybe a specific point that you want to highlight, that you want to have stand out. So in both of these examples, that's it's highlighting Team 3's achievement. When you're using color, you're usually using it to create some sort of contrast, and that can be to assign value along a scale. So as you can see here, that's going from dark to light. So this would be some kind of scale. You can use color to assign contrast between different variables. So this might be if you have strongly disagree to strongly agree. Your disagree would be over here, would be on one end versus agree on another end. And then to just distinguish between categories. So if you have a bunch of different age categories, for example, age would just be assigned a different color along a color scale that you have. And you can also create color with, or create contrast with icons. So each object gets a different icon, which allows you to very clearly see the difference within your graph. All right, so that's creating visuals and looking at visual elements. But let's talk a little bit about how those visual elements can be pulled together to create narratives within the visualizations you put together. Crafting a narrative ultimately starts when you're analyzing your data, when you're looking for both similarities and differences within your data set. And as you do that, certain elements will begin to stand out to you, and those build the foundation of your narrative. So some similarities and some differences will stand out, and whatever is most interesting or is most impactful will ultimately be the narrative behind the visualization that you create. So some relationships that you may look to explore include looking for consistent patterns between data points. So patterns that always seem to exist or always seem to be there. Correlations, so relationships within your data, particularly interesting relationships that exist. Or outliers, so this is unusual or irregular occurrences, and these often have some of the most intriguing stories. So the reason why certain data points are outside of the norm, that they're not consistent with all of the others. The stories behind those may be what you want to focus on within a visualization that you create. And as you turn those data stories into narratives, some questions to ask yourself might include, what issue is the data addressing and why should your audience care? So making sure that you're engaging your reader from the get-go and making it clear that the information you present is relevant to your audience. How does the story support the argument, or how does the data support the argument that you're making? Are you showing it in the right context for your reader? And is it leading to some sort of deeper insight? And then what should your audience take away from the visual? Define what the conclusion should be. It doesn't necessarily have to be direct or prescriptive. You don't have to necessarily tell the reader up front what they need to take away, but there should be some sort of point there. It should exist. All right. So this graph is looking at the percent of the US population by age group, going from starting at 1950 going to 2060. So it's a projection. And it has male on one side, female on another. So looking at it for a little bit, what story does this visual tell us about the US population? Or maybe even more specifically, what story does this visual tell you about the US population? Right. So we're sort of when the baby boomer population was first born, there's this huge youth bulge, which as the baby boomer population ages, we're losing it. And they're and by about 2025, they're no longer going to be the largest cohort. So there are a few different interesting stories here around the change in the U.S. population, sort of the changing face of the U.S. population. Maybe even some interesting stories around about what that might mean for the U.S. population. Oh, there may even be something here to see about do men, sort of the life expectancy of men versus women. Maybe the more you study it, you could also see something there. And to Diane, to your point, you're right. You do have to watch it a few times to digest the information, which personally is part of why I like this in GIF form, to be able to continue to watch it and digest it a few times. I've also been looking at it quite a bit, but so yeah, so there are a number of interesting things you might be able to look at and to learn or take away about how the U.S. population is changing and what that says about the United States. Okay, actually, let's stop for a second. Are there any questions at this point? Let me take a couple minutes. Okay. There will be plenty of time for questions towards the end. So not seeing any right this second, let's continue to talking a little bit about how graphs can mislead us. So everything we've talked about thus far is how you can put together good visuals and have and craft a narrative within that visual. But all of those components can also be used to mislead your reader. Let's shift gears a little bit and look at 5 ways that graphs mislead people and tell maybe inaccurate stories about data. The first one is by omitting the baseline. So in most cases, the baseline for a graph is 0, but writers can skew how data is perceived by making the baseline a different number. All right, so looking at the example here, why is this graph, why is the misleading graph misleading? Right. So it doesn't start at 0. And why is it a problem that it doesn't start at 0? Exactly. So it doesn't start at 0, which means that they're trying to show a much greater difference between group A and the other two, when in reality, the difference between the three isn't actually that large. So by changing the baseline here, they're able to shift your perspective on what the difference between the three groups is. All right, you can also manipulate the y-axis. So by expanding or compressing the scale on a graph, you can make changes in your data seem more or less significant than they actually are. All right, so same question. Why is the misleading graph misleading? Right. So in this example, they've spaced the y-axis out so much that the change between data points, it looks like there's very little change year to year. It looks like there's very little change between your data points. Whereas in the more accurate example, the scale of the y-axis actually matches the spread that the spread that actually exists within your data, which means you're getting a more accurate picture of the year-to-year change within the data. You can also cherry pick your data. So sometimes writers may only include certain data points or a certain subset of data to depict, to reinforce a very specific narrative. So what's happening in this example? Correct, exactly. Whereas the full data set obviously shows some initial growth, but then a pretty significant downward trend. The the more misleading graph has cherry picked information only from the 4-month upward trend, which makes it look like everything's going really well, when in reality, there's, it looks like there's been a crash of some sort in whatever the data actually is. um, so Right. So there could be some reasons why you might only show this period. If this is the period you're being evaluated on, then that growth is really great. But if this is what the full picture of data is, you would still probably want to show the full picture of data. And then you could in a separate graph maybe highlight just this one period. We always want to show the good narratives, right? We always want to show the pieces that are going really well. But if that means that we're cherry picking or we're not showing the full picture, then we are still misleading people, which is obviously something we want to try to avoid. Okay, and then using the wrong graph. So I spoke at the beginning of spoke at the beginning of this presentation about how choosing the right graph for what you want to try to say about your data is really important. And so using the wrong graph can really skew what your narrative is. Um, and if and so sometimes writers will purposefully choose the wrong graph in order to mislead people. So here, using, they're using a pie chart versus a bar graph. If you wanted to show the difference between, for example, 3 categories, you want to use some sort of comparison chart, like a bar chart, not a pie chart, because it's going to show the wrong. It shows the wrong narrative. It's the wrong type of comparison. And then lastly is going against convention. Sometimes going against convention, sometimes being innovative can be really great and can show you. So in the last example, there's a question on So would a pie chart be okay if they had included the raw numbers in addition to the percentage? So it's still, in this example, wouldn't have been okay, because if you notice, I'm going to very quickly do this math in my head to make sure I'm not. Yeah, so because if you notice, pie charts are part to whole. So meaning that you don't want to go over, you don't go over 100%. So if you notice, this is going well over the whole of 100% by quite a bit. So it doesn't make, so there's, in this scenario, there's no reason why you would have used a pie chart. You would want to stick to something that's going to compare that would compare the values of the 3. A pie chart here might have made sense if you wanted to show say you wanted to show the composition of team A, and you wanted to show maybe male versus female, men versus women on team A, for example, then a pie chart would make sense. But it doesn't here. Okay, so going against convention. So as I was saying, sometimes going against convention can lead to some really innovative ideas in data visualization. But over time, we have developed certain standards for our data visualization, and flipping those conventions can lead to creating confusion and misleading our readers. So what's the problem with this misleading graph? Why is it misleading? So shades of gray is maybe not the best example. But so in general, when we do density, we generally associate lower density with lighter shades, and then we associate higher density with darker shades. So by reversing that and doing a darker shade with a lower density, you're reversing the general convention people have, which means that if someone weren't to look at this scale, they would probably misread this graph and assume that, for example, Alaska has the higher population density than, say, Texas, which we know isn't true. Whereas over here, they're following the more accepted convention of having a lighter shade correspond to lower density, and then a darker shade correspond to higher density. So when you read the graph, you say, oh, right, Alaska has a lower population density versus looks like Virginia. Virginia has a much higher population density. That makes sense to us. So someone wouldn't necessarily have to look at the scale to correctly interpret this heat map. Okay. Any questions before we move on? Okay, so not seeing any. I can talk about principles for good data visualization and what to do and not to do all day. But in my personal opinion, the best way to really learn data visualization is to look at is to talk through examples and to look at examples of places where data visualization maybe didn't work out the way that someone expected it to, and to talk about how you would do it better. So take a look at this example and let's talk through what's not working here. The 3D, right? So it's hard to tell what exactly the proportions are supposed to be. What else? Far too much text. In fact, there's so much text, it almost makes you wonder why they bothered with the graphs at all. I agree. Yes, it's unclear what the focus is meant to be. So there's so much going on that it's unclear what exactly this visual is trying to tell me about either this person's portfolio or what the stock market was trying to do. The background color isn't helping. It's sort of it's in the pretty much the exact same color palette as the visual, so it's blurring everything. Is this exactly, is this a title? Is it an explanation? Is it a caption of some sort? So there are a lot of different there are a lot of elements going on here, all of which are leading to sort of the same conclusion of there's just too much happening and the reader doesn't really know, at least at a quick glance, what's happening and what you're supposed to learn from this. So this is the exact same information, just presented differently. Is this better? Worse? Better, okay. Easier to digest. Why? Don't have to read. Yes, that's what I agree. That's what I want out of my data visualization. I don't want to have to read things. So, it's really clear that the portfolio suffered a loss, and then you can tell where the loss came from. It's so clear. Is there anything you still don't like about this? It's a bit boring. I agree. There's no timeline. Okay. Maybe missing some labels that could help a little bit with some clarification about what's happening. All right. For the sake of time, we're going to move on to this one. So I'm going to ask a slightly different question. What is working well on this visualization? Okay, so the orange line, which is supposed to be a trend line, that's helpful. It stands out. It's too much. It's too much for my eyeballs as well. Is there anything else about this that anybody likes? The two diamonds. So the two diamonds are supposed to show the start of phase one reopening versus phase two reopening. So kind of helps show where those two phases are. It's kind of helpful. All right. So again, for the sake of time. Okay, so it does label the raw figures for each bar, which can be helpful if you're taking the time. So like that the phases are marked, it might be better if it were shaded. Okay. So going back to the bars and the numbers, so that can be really helpful, especially if you are going to take the time to sort of dive into this chart. Having those numbers is great. For the sake of time, I'm gonna go ahead and show you the improved version. So let's see, Maria, you mentioned shading phase one and phase two. That's what this one does. Makes it a little bit clearer. It still has that average line. So do we think this one is better, worse? The spacing on the axes is better. They're much easier to read, right? The scatter, so right, the scatter plots may be a better way to show the raw data. It's a little bit easier, but still hard to grasp quickly. It's trying to present quite a bit of data. Is on the y-axis. So the number of new hospital admissions. And I'm not sure if there is a scale to it. Is it the thousands or the hundreds? I'm not sure. It's not clear. So, but that's a good point. It's not clear if this is just supposed to be 10 new admissions, or is this supposed to be 100 new admissions? Is it 1,000 new admissions? That's a really great point. So the axes could maybe be, or especially the y-axis could maybe be a bit better labeled here. Okay, we've got about 10 minutes left. Let's try to do one more quickly, because I quite like this example. So what's going on here? It looks like the other category is only in Maine, right? And you can note, you also have that problem with Asian. It looks like they're only in sort of the very tip of Washington and a tiny subsection of Maine. Trying to do some sort of change over time when projected onto a map is incredibly complicated, because it looks like it's unclear, because it becomes incredibly unclear what this is trying to show. Is this trying to show change over time, or is this trying to show where these various groups live within the United States? It's very easy to misinterpret what this map is trying to show, or what this visual is trying to show. Anything else? Right. What exactly the change is? What exactly the change is isn't clear. So this is the exact same data, but from the Pew Research Center. So better, worse. Okay. We've got one vote for better. Much clearer once you remove the map. All right, different colors might have been nice, but in general, much better. It's much clearer. It's much clearer that this is a trend. You can very easily see what the trend is, what years we're looking at. Okay, we have more examples of these, but we're going to have to skip through them because of time. Let's talk about additional resources. Starting with, I mentioned that there are lots of resources to help you match visualizations to what you want to say about your data. And here are three, starting with the Data Visualization Catalog, which is a website. And it has lots and lots of different visualization types. In fact, probably more than you ever thought existed out in the world. What I really like about it is you can search by function. So you can search by what you want to say about your data. For example, if you want to make comparisons, you can search by comparisons and it'll give you all the different chart types that make sense for comparisons. And then if you click on one, it'll tell you, for example, it'll tell you what a bubble chart is. It'll give you the anatomy of a bubble chart, tell you similar charts, and it'll give you tools for how to generate that specific visualization. So this is a really, really handy website, and it's literally just datavizcatalog.com. And this is a very similar tool. It's just static. It's the visual vocabulary from the Financial Times. Along the top, it has different categories of functions, so different categories of things you might want to say about your data. So correlations or rankings or change over time. And then underneath each one, it just has different visualizations that that are included under those categories. And if you tuned in last month to talk about qualitative data, you may remember that Elizabeth mentioned the qualitative chart chooser from Stephanie Evergreen. And this helps you choose visualizations for different things you may want to say about qualitative data. So additional online courses if you're looking to learn more. So a couple courses from LinkedIn Learning that I would recommend, which are great introductory courses to jump off from everything we've talked about today. And then FSI has lots and lots of great offerings, both in person, once we can do in-person offerings again, but also some distance learning courses. So if you just go to the FSI course catalog and search for data visualization, it'll come up with all the different courses that you can look at. If you're looking for tools, so how to actually create visualizations, I recommend starting with Excel. It is the best. I personally think that it is the best starting point and can actually do some really great creative things. If you feel like you've mastered Excel and you're looking for something a little bit more powerful, and especially something that can help you start to create dashboards, then moving on to something like Power BI or Tableau is sort of the next step up. And then you can also do visualizations and dashboards with some survey platforms. And for example, the evaluation division uses Qualtrics, where we can do some pretty cool visualizations and create dashboards from survey data. And if you're really just looking for inspiration, these are 4 places I recommend going. You can look at the Tableau Public Gallery to see visualizations and dashboards that other people have created and made public. Information is Beautiful and The Pudding are both online magazines where people have, where the writers have created really amazing, basically online articles that are data based and interact with interactive graphics that are really interesting to read and lots of fun to play with. And then Junk Charts is where I got most of our bad to good examples, which is a great place to go to look at examples of visualizations that maybe didn't start off particularly well, and then to read through his blog, the author's blog posts about why they maybe don't work, and then to see how he transforms them and why he makes the corrections that he does. And lastly, you can go to the Evaluation Division's Diplopedia page to find all of our previous evaluation seminars, including a recording of this session by the end of the month. And then you can also find these recordings on our public website. And if you still have questions, please feel free to email us. Next month, we will be continuing our seminar series talking about the success case method. Oh, and that's everything I have. There was a request for, real quickly, I'll just, it's the DataViz. There was a request to just pop these links on up real quick before we left. So here are these links for anyone who wants to grab them. You'll also be able to pull them from the recording once it goes online. So that's it. If there are any questions, I will stick around for a few more minutes. But thank you all for joining us.